All right. Good evening, everyone. So we'll be getting started today. As I promised, we'll be having a session around privacy. But today we'll be actually like focusing a little bit more on Arcium, and let's have a guest in the house. I don't know if you guys can hear me, but yeah. So we have a guest in the house, and that's Dara. So Dara, previously, I don't know for those of you that actually like attended Startup Village, if you attended the Startup Village, you should actually like know Dara, and yeah, so has experience working at Solana Foundation as a developer relation advocate, and it built a couple of stuffs with Acume. And yeah, so I will just hand over the mic to him to actually like maybe do the introduction maybe very well if I did not do it. But then I think we will now get started. So yeah, there I have the floor.
Thank you very much, Alex. You did a good introduction. I couldn't have done it better. So, yeah, my name is Dara, and I'm going to walk us through an introduction to understanding Archeum. And it's going to be like a somewhat watered down version compared to how it's outlined in the docs or any other Archeum resource out there. So we will not be doing anything code intensive, but there are code snippets so that you just understand things so you can go ahead and try things on your own. So without further ado, I think I'm going to start now. So first thing, even if you go on Archeum's docs, I think the first thing you see is this line: computation is broken. And basically, they're trying to emphasize that every time you use a cloud service, every time you send data to a server, or you interact with the blockchain, there's a fundamental vulnerability that your data must first be decrypted before it can be processed. So there's no hidden information. So a traditional computing model, this is basically the flow. Your encrypted data has to go through the decryption stage, and once your data exists in plain text anywhere, it can be read or accessed by pretty much anybody available on the public space. So just think of it as say you hire maybe one of your relatives is a lawyer and you hire him to go through your sensitive documents and you put him in your like in your workplace. But then your office is like the office you put him in is glass, like it's glass walled and it's see through and everybody is just passing and everybody can see what he's actually doing. So the lawyer works of course you can say that you trust the lawyer, but then you cannot trust every other person that is passing through um, that office. So that's how traditional cloud computing works. Your data, once decrypted for processing, is exposed to whoever operates that infrastructure. So there are consequences for for such approach. Say in healthcare now, where you require privacy to analyze something, but the patient data is always going to be public, and obviously for most people, you don't want to give out your health data publicly. And in finance, banks want to collaborate. They say they want to build something to detect fraud better, but they cannot share their data amongst themselves because again, private data. You can also go into consequences in AI and machine learning, where training models are trained on sensitive data and are exposed to the model operators. And you can the consequences go on and on, DeFi and all. So the solution, I'll just basically explain what Arcium is. Arcium is a decentralized supercomputer that can perform computations on encrypted data without ever decrypting it. So that vulnerability we talked about never occurs on Arcium. So you can just basically think of it as compute without revealing. it does all the computations without revealing. So the key part here, or will I say the magic of Arcium, is the multi-parties. So it's called MPC, multi-party computation. And as we go along in this session, we'll talk about that more and more. So you can think of Arcium as, um, say, you take a picture now, you cut that picture into 10 pieces and give it to 10 people. Those 10 people have a particular part of that picture, but none of them actually know the full picture. So that's basically how you see those parties. Like those parties help you to compute to make the full picture, but none of them actually know what the full picture is. So without a single worker ever seeing the whole image, and the beauty of it is that even say if four of those guys come together and say, okay, let's even try to see how this larger picture is technically impossible for them. And we'll talk about that when we're talking about certain MPC protocols. So the next thing we'll talk about is the core concepts. So first off, we'll talk about MPC in detail. So MPC is basically a cryptographic technique that allows multiple parties to jointly compute on a function. So basically, you put in your inputs, and those inputs stay private, and the computation happens on those inputs, and you get a result, which is also still encrypted. So I'll just go through a classic um, MPC problem now. So say for instance you want to there are two people that want to know who is the richest person between them, but they do not want to actually expose their balance. They can basically use an MPC protocol to, so in this case here, the MPC is basically comparing these two values, these two inputs together and returning the, not really returning the inputs, but just saying that, oh, this person with the highest input is the richest person without actually showing their wealth. I hope that gives us like an idea of what I'm talking about because we need it as we proceed. So we'll now go into how um, Arcium uses MPC. So as I mentioned earlier, with the Alice and Bob example, you can also think of it like a secret recipe. Say three chefs want to know the secret sauce that has the most ingredients, but none of them want to actually reveal their recipe. The if chef can write the ingredients count on a card and they can put the card in a specific box, that box is like the multi-party, the MPC environment. We'll talk about MXCs later. So execution environment later on. So basically, that environment takes in those inputs and it just basically says, okay, chef B or chef A has like his sauce has more ingredients, and it doesn't say like what the recipe is about, all of that. So now we'll talk about secret sharing process. Splitting data into fragments distributed across nodes, so no single node processes the complete information. Like I said with the image explanation, yeah, an image is cut into 10 pieces and given to 10 people. So here is showing a simple integer split into um, bits. Here is quite straightforward because these are just numbers concatenated to each other, but in real use cases, there will be like different numbers. So 42, say 37, other numbers being split into shares. So no single node knows that it's actually 42. They just have their own portion. And if you need to reconstruct them, those nodes don't also know the final value. They just know that this is my own part. I've contributed my own computation, and I've given my own results. So they are just individual ARCs nodes. So we'll talk about ARCs nodes too. ARCs is a Latin word for structure. I can't remember now, but we'll get to that. So next up, here I'm showing like a basic. If you run Arcium init, which we'll talk about later, if you run Arcium init, basically it's built on Anchor, so the commands are pretty much the same thing. When you run Arcium init for a new project, you get this particular file path that helps you to manage your MPC circuits. So here I'm just showing a simple function to add numbers privately. And we'll also talk about these encrypted shared types. It's a type or an Aki's framework, and it helps you to just encrypt inputs from the client. So key things to note here are the method. So these two Akis basically splits the encrypted value into those shares that we talked about previously and lets you do all the computation in secret. So the addition doesn't happen on whatever value this A and B are. It happens on the shares value, not on the plain text value. So when you are done with all of this, you can now use from Akis to get the answer. And the only the user or only the original client can decrypt this with their own public key. So we'll just quickly talk about the protocols, the two protocols that Arcium currently has, and basically we'll talk about their differences. So Arcium provides two MPC protocol backends, and each optimized for different trust assumptions. So for Manticore, I think Cerebrus is the one I've pretty much been using. But for Manticore, it basically says that you can just basically think of it as your own personal stuff. Like you know that you can trust these nodes and you can just basically do whatever you want with it. Like you can run wild with it. But then if you are going to be doing like something requiring trust and say you are dealing with financial apps or DeFi, or you need something that is really secure, you want to be using the Cerebrus protocol. And you said this like you can set this in the arcium.toml file, which is auto-generated when you run Arcium Unit 2. So for Cerebrus basically says that even if it's just one node that is honest, you are still safe. That means even if there are 10 and nine of them are ganging up against you, if you have one honest node, you are still safe. So that's basically what most of these Arcium projects use. So I'm going to go if you need to read it more on Cerebrus, there's documentation on that, and maybe you want to test out their pros and cons because both of them are pretty much designed to do different things. So I'm going to go into the key components now, key components of the Arcium network. So there's the Solana side, which is pretty much common, and it's just your normal Solana program. You have your program slash source slash library.rs, and that's where you write your normal Solana code. And this ArcOS is basically Arcium's operating system that helps to run computation. So a cluster is basically a group of nodes. That's all it is. Okay, I remember it now. Ax is Latin for fortress. So each of these are basically you can see them as they are independent fortresses that run their own compute individually, run their computation individually. So you can think of them as individual bank vaults location, like each holds a piece of their own data and they do not have to sort of interact. And so yes, clusters are group of Arc nodes that collaborate on computations, offering customizable trust models. So this is basically the Arcium network. You have the Solana side where you write what you want your program to do. Then on the encrypted side, using the circuits, you basically define how you want your like what you want to keep hidden and what you want the public to access. So that's what we're going to talk about next. There are two encrypted types basically. So these encrypted types are they help you they help you determine how you want to how you want your data to be private basically. So for the encrypted shared, this is something that a user might want to look at frequently. Say like those numbers we saw in the first function add together. A and B are encrypted shared types. So these are things that you want to encrypt on your on the client side, but the user still has access to it. But if it's an encrypted MXC type, the user cannot have access to it. So let me explain what I mean by that. If say now there is a like Jupyter, their other book. Now Jupyter's other book is pretty much open, everybody can see it. But if you needed something that required people to do some private type of trading where you don't want any other person to see it, you want to create that in an encrypted MXC type. I hope that makes sense.
Yeah. So I was about to like ask you what the difference between the shared and MXC type is, but I think it's pretty much self-explanatory. So for the shared side, if I need the user's inputs right before it gets encrypted, it's actually like I'll use the encrypted shared type. But if I want it to be predetermined already, like is encrypted even while using the app, then you now have to use the MSC. Correct?
Yes, yes. So I'll just go over that again. So like um for encrypted shared, the user
Mm.
can encrypt anything, send it to chain. User is in control, but the MXC can also work on this. Let's say the MXC needs to process something on it. Let's say because in the end, it's the MXC, the environment that actually does the anything you do. Like that, those two values, A and B, they will still be
Mm.
added in the environment. But then the difference is that for anything that is MXC type, only the MPC nodes can decrypt it. User cannot see what is inside, and it is perfect for shared state. So, like what as I mentioned before, other books and all of that. So, internal state, say you want to keep something internal and sort of like centralized. Even the users do not have access to it. So, you want to use like an MXC type.
Okay.
Yeah. Okay. Good. So, there's an example here. So when you run Arcium init, this macro comes doesn't come automatically, but this is an Akis. So Akis is a framework that Arcium wrote so that you can write basically write NPC circuits, build your own NPC circuits. So this macro, when you see this instruction macro, it basically tells you that oh this function can use some can use methods or can use functions from Akis. So here we're seeing that these params here are shared types, but then the other book look at this now. This is a function to submit an order to say a swap platform.
Okay.
So the other book is MXC only, so no other user can see the orders. So this other book here, this book CTX is MXCOD. Every other user can sell, they can submit their own parameters, all of that. These parameters are, say, you want to buy USD at 10, all of that information, and TVL, any setting you want to do, these are like shared. Any other user cannot see it, but you, as a user, your own, you can basically do anything on it. But for MXC types, they're pretty much like hidden to every other person. So again, we're coming back to this function. This Towakis basically lets you to convert that this parameter to Akis, like a type that can be like they can make computations on. You remember we talked about those secrets, those
Yeah.
shares. Yeah, so those shares, this is what converts all of those parameters to the shares. Then at the end, it still goes back to from Arc is something that you can decrypt on your own end. But this is for so I'm going to go through this now. Let me see if I can zoom out here. So there are 5 stages for all of these computations that we're talking about, and I'll be going through them one by one. So the first stage is definition, and it basically says like, oh, I'm giving you a blueprint of what I want to compute, and this is all of this is done on the Arcis framework. So if would see we can run a few things, but like when you run Arcium init, an encrypted IX folder is created. In that folder, that is where you do everything encryption, encrypted instructions, everything encrypted. So it's somewhat different from the normal Solana program that will also be generated, but like that one is just for encrypted stuff. So this is where you define your stuff, define how you want your function to go. Let's say now for that simple function that we saw add together. So it's just like, oh, I want to add A to B, but you can go as wild as possible. Although we'll talk about some constraints that you cannot do within the computation. But the second stage is commissioning. So the commissioning is basically you're saying like the computation should be instantiated with actual arguments. So apart
So,
from saying,
so let me comment. So, on the definition is just like, okay, these are the things I want to be encrypted. This is like after maybe building your programs and all that. The definition is okay. These are the things you should encrypt. This is the order I want it to be. This is the order for encryption I want it to be done and everything. And then once you're done, it kind of generates like an maybe an encrypted public key.
okay, so definition also it can be that, but it's more than that because
Okay.
after you say like this is what I want to do, you'd also say like um let's go back to the add together function. So like I'm just trying to keep it simple. You said I want to add A and B together, but I don't want people to see it, right? So that's basically how definition goes. So if we're going a very if we're going as like as complex as possible, we can think of say a user wants to swap USDC for
Mm,
Sol, but he does not want other people to know. So he says like, oh, I want you to debit my wallet this so amount. I want
mm,
blah 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 blah. Like all of those details is where
yeah.
definition goes in.
Okay.
Yeah. So like obviously like you cannot do those things on the Solana program side. You need the Arcis framework because that is what has all of the things that require you to build MPC circuits. So in the second stage, you are just basically now saying that, oh, I have this blueprint, I have this foundation. Now I need to instantiate them with actual arguments. So there is something called an arg builder, ARGB builder. So it basically just allows you to build arguments within the Arcium class. Function new that you can just dump in your stuff. Say you client pub key, client this whatever price, quantity, side, anything just is possible with the ad builder. So I could we'll probably touch on this like at the end of like see actual code at the end of it, but I just want to keep it simple so you understand the flow. So on the third stage is the main pool placement. So the computation enters a decentralized queue waiting to be processed. So of course people say Solana does not have a main pool, but I think this is more of like an Arcium structure
Mhm.
because after stage three, then this is where in execution the ARC nodes then perform the NPC computation. But
So
then
everything is still happening like in the Arcium like operating system.
yes,
Okay.
but on stage five, then you're now getting results returned back to you. And let's say you're logging things on chain. Those are now things that are now happening on Solana, like normal things you can check on the Explorer and all. Excuse me, I need to. Oops,
Sorry.
I thought I muted myself. I'm sorry.
No problem.
So I think we'll talk about one of the important parts, like the execution. So I try to break down what happens during execution. Remember, we talked about how a cluster is a group of nodes. So this node, one node could be in Nigeria, one could be in Germany, one could be in America. It doesn't necessarily have to be in the same location. Just how validators are on Solana. So when you encrypt the now think of this is like a simple or simple structure, and think of it like what just have a mental model of the add together function. So this is one share, this is another share. Let's say A and B now. So in the protocol, the nodes are computing on the shares jointly. I'm saying jointly now, but it's not like they interact or share data among themselves. They just know that our goal is to execute whatever the user said should happen in definition and commissioning. So there's also the BLS signature, just basically to attest to the result, and that's an Arcium's way of attesting. But then the return and everything goes back to stage 5 that I talked about, which is callback. So just know that the execution is in three phases. First, verify that I can even process this, like I have capacity to process whatever you are bringing. Then you process the um, like you load the inputs, execute all of that, the logic. So it could be like multiplication, addition, anything, but those computations are going to be processed secretly. Then finalization. So this finalization is what leads to the callback, in the sense that whatever result shows here, whatever result comes from the computation has to be returned as a result. So results are delivered, and then the on-chain state is updated. So you might want to, in the code, like in the source code, there's a function. I don't want to go deep in that, but like there's a function called await finalization. So that basically waits for this to execute and then sends an event to on chain. Sends an event on chain to basically say, oh, this work that you gave me to do, I've finished doing it, and this is the proof that I have done it. Okay, so now we can talk a little bit about constraints, because Archeum is still in. I would not use the word still in development, but Archeum is still developing. So there are a couple of constraints, and these are very valid constraints because, for instance, um, let's say you want to do like an iteration from 0 to like this range now. Compiler knows that, oh, this is already 10. So there's no, you're not leaking any information. But then when you now say like, um, when you're using while, how do I put this? Uh,
So while an input is kind of true, you should do this, but it doesn't know whether it's going to be like false at the end of this. So maybe constraints that it might not really like be determined at the end.
yes,
But
it's
for
not fixed. It's
for loops
because
are like maybe an array of items that are already like available. But then for while loops, it doesn't really like know maybe if the action is actually going to change at the end. So maybe constraints that it doesn't know like the outputs at the end of the day, or like sorry, the outcomes at the end of the day.
exactly.
Is it
Thank
something
you.
like that? Mm.
Yes. So like if we go down to like computing, there are like three rules of stuff that algorithm should basically follow. So like if the computer doesn't know that this can even run, or it can terminate, basically that's the word. If the computer doesn't know that this can terminate, there is that variable iteration that is not as fixed as when you're using for, that there's a range of um, like you are going from a certain range. So this is also another constraint. Both branches execute and result secretly selected. So see a first branch explicit pattern, else then this does. But if it is in um look at this again, like break, it is looking it's basically looking that, oh, this is exactly where I, so if it found that say the 50th index, you're basically looking information that, oh, that's where the match happened, compared to when you're doing like two double parts that you're saying, if this happens do this, and if this happens do this. So I
Mm.
hope that,
I think the last one is kind of like confusing.
okay, let me go over it again. So if you are going through say from here to 100, and you are saying that if if you find a match break, let's say you reach the 50th,
Okay, okay, that match break is like if you find this break, meaning that it's going to leak that actual data of where it's going to break, unlike
exactly,
the if else just do this. So you don't know whether this is going to happen or the other one. But
yes,
then for
so
that, yeah, okay, continue.
exactly, yes, so I'm just going to go through like a few, um this is not fixed though, it's not fixed, but then doing when you're doing anything NPC, you know that it comes with a cost, and that cost is, it is determined, it's dependent on how much of operations you need to do, like arithmetics basically. So C addition is basically, is nearly free. Why? Because you're just talking, the integers are directly interacting with each other, and there's no, the processes are not much. One plus two does not really have any other process underneath. But if you're trying to compare, say like, is 47, like in that first example we talked about, like the millionaire problem, what the computer sees is not those 75 million and 50 million. It actually has to convert those numbers to bits and first check, like bits by bits, like is this bit bigger than this bit for each of them. So those are so many steps in between. And those bit by bit operations usually take, like, because first these numbers have to first be converted into binary before they can even be compared. So same goes for stuff that requires more iterations and all of that, division and all. So I'm just basically giving us an example, and not an example now, but like an overview of how NPCs cost them. So when you run like an Arcium program, when you run, or an Anchor program rather, when you run Arcium in it and the project name, say your project name is my Arcium app. This is basically the structure you get, like the template you get. And in this Archeon.toml file is where you use that backend I was talking about, Cereberos, and um, Maxicore. I keep forgetting these. But then this is where you set that configuration. You can also set like timeouts, other stuff. You if you run it on your end, we should be running it now, but I wasn't just prepared to do like a real coding session. I just sort of wanted to give like a dummy introduction to
Yeah,
Archeon.
some other time. Let's.
Okay, so this is an important folder to look at. This is where everything encrypted goes into, and this is where you're importing, like using Akis. So Akis, as I mentioned, the framework is like a crate. Will I call it a crate? Yes. So it has like it has functions underneath, from Akis to Akis, the Arc Builder, and a lot of other stuffs, even types as like encrypted booleans. So there's quite a lot of things to unpack in the Akis framework. And then you can see that this is basically how an Anchor project looks like, except from the encrypted instruction and the Archeum.tml configuration file.
Okay, wait, before you actually like scroll further. So the Solana program goes to like the main my app. Why the if I'm right, the definition side of like the whole compute cycle is actually like in the encrypted folder.
Yes. So anything that you want to, any instruction that you need for encryption goes into the encrypted instruction here. So when you run like Arcium build, this is what Arcium build does compared to Anchor build. Anchor build will just go through your anchor.toml, check your lib.rs and build all this program stuff. But then Arcium builds your, these are called circuits, like whatever instruction here comes out as a circuit. So those circuits are dots arcis files. You see them, they'll build in your, there's a build folder where all these encrypted instructions go, like the build when it builds. So those .arcis files first, like they build first because they have to first validate that I can. It's even possible to do anything. I mentioned that there's process like pre-processing, processing, and then finalization. So that pre-processing checks that all of the things that you define there are they even computationally possible, and if that doesn't go through, your Solana program will not build yet. So did I answer your question?
Yeah, yeah.
Okay. Oh, so we're almost close to the end. I thought I had more things to say. Maybe I'm not following my script very well, but like um here I'm now talking about like things that you can real world cases, like real world use cases of Archeum that I have used personally. So um here is just like a is a dark pool. So I'm building a dark pool as a side project, not a side project, but like here you can see how traditional dexes work. Like you can tell what somebody wants to buy because this data exists in plain text already on the blockchain. In fact, there are bots sitting down waiting for this data to land on chain so that they can front run you or quote you like a higher price so that you want to buy it for 1,000, but they've seen it before it happened, like before it executed, so they'll buy for less. So there's a lot of things that people can do when they can see your data before you trade. And this whole MEV bots is a business on its own. So but in an encrypted case, you would find out that you can't see any other thing, anything basically until it has been executed. And this execution state is where the finalization is returning an event on chain to just say that, oh, this thing has already happened and I'm logging an event on chain, basically like every other Solana program. So another use case, now this case use case is, although I call it private AI, but it's more like in a medical, from the medical standpoint. So say three hospitals need to collaborate, but then patient data is too sensitive to just send as a raw format or just send like that, maybe an Excel spreadsheet. So um I mean, people, maybe some companies are breaking policies and actually doing this. Like, I'm sure even OpenAI just trains a lot of private data together. So, but if you really need to, if you're when you're conscious about your privacy and all of that, you start to think about the implications. And I think this is one of the a use case that is really interesting to try out. So although in this case you'll be using Manticore because I explained how Manticore um, is more suited for stuff like this because then you cannot just trust some node that is in Japan or so. You have to use your own nodes, and there's nothing like oh, if only I was talking about how there's a dishonest architecture and honest architecture. So if you are in control of your nodes basically, and you know the type of data you're putting into it and all of that, compared to Cerebrus where everybody's fine as long as one node is being honest. So
Yeah.
I think that comes to the end of my um, talk about an introduction to Arcium for
Yeah.
dummies. I,
All right. I think pretty much did fine. I'm not going to lie. And funny enough, it's pretty much, I would say it's not like my first time going through Arcium, but like, I'm not really like had time to go through the documentation and have like a very like general overview of what it looks like. I only know that Arcium helps you to like do stuff privately on Solana and all that. So and that's actually like one of the reasons I decided I would kind of like have this conversation and see like an overview of what privacy looks like with Arcium. So maybe some other time we could have like some other cool stuffs. Maybe we could experiment or like build out like a simple DApp and all that. Yeah. Can you like share the link to me or share it in the chat so that I'll drop the documentation for any other person that wants to like build an example. But yeah, there are lots of use cases for Arcium. That's actually one good thing. And also they are live on mainnet the last time I checked. So it means that there are so many things you could actually build around DeFi that is currently like available now through Arcium. So I don't think the limitation has like much it's offering. Sorry, the limitation has like much it will do to you currently. I think the first product on Arcium is Umbra. Is there like any other one?
I think a newer one is Anon Mesh. I'm not sure. So the thing is, I'm actually not sure on the state of Arcium working on minutes, but no one said anything about that. But there's
Okay,
Anon Mesh and
yeah,
there's Umbra.
yeah. So these are like products you can actually like try out that are built on Arcium currently. But yeah, so thank you very much, Dara. I think we could do more of this next time, and we'll also like see how this goes. So there are also like so many stuffs around privacy on Solana. There is the private the privacy cache guys. They build on Arcium. I don't really think.
No, they have
Then
their own
okay, then we have Inco and the rest. So the privacy
Magic
actually
Block,
like hello.
Magic Block too.
Yeah,
Then Noah.
yeah, so there are lots of privacy programs and privacy projects currently on Solana, but Akim is actually like one of the upcoming and pretty much will I say industry standard one for now. So we also have like Magic Block, we also have like as I said earlier on, privacy cache and the rest. So yeah, let's just see how it goes. We'll talk more on privacy and the rest so later. But yeah, thank you very much, Dara, for joining in. I think maybe this is where we're going to be like ending the call. And if there's anybody that like has any question, you could actually like share it in the chat, and maybe we could take it up from there. If
So
you have any question,
I'm going to share
yeah.
like I made some a comprehensive documentation on what everything I talked about. So I'm going to share it with you if you can.
Okay, okay, okay. I'll just share it once we are done. All right. So thank you very much, everyone, for joining in. We'll see on Sunday. Yeah, on Sunday during our dev call. All right. Bye, guys.
Bye.